Hello guys, welcome once more to class online. My name is Tutodami and this is Jamb Physics 2013, which I'm looking at different aspects of this question in different lights, which I will deal with very technical part of physics in this series that will so much teach you a lot about Jamb Physics. Now stick to us. Don't forget that if you learn something from this series and you want to get more content from us, you can click on like button and we'll get to reach you with better informative and educative stuff that will better place you in towards distinction in physics. Let's get to number 41. An electric device is rated 2000 volts, 250 volts. Calculate the maximum current it can take. Now, I don't think that is supposed to be 2000 volts. 2000 watts. That should be 2000 watts. Then 250 volts. Calculate the maximum current. So current, you are giving power already. Now what is the power formula for electricity? Now that power formula is very simple. It is just IV. So you just do P equals IV. That's the power formula for electricity. Where my current is what? Now, but I'm told to find not the power but the current. So I'll make the I the subject. That will become I equals P over V. That's if I divide both sides by V. That will become I equals P over V. What's the power? 2000 watts. Okay, over what's the voltage? 250 volts, and that will give me 8 ampere, and that is the current. That's the current of the system. Don't forget the current in power formula is IV. Then I, that's current, where I am P is power, I is current, and V is voltage. So the I is power over voltage, and that will give me 2000 over 250, and that is 8 ampere. Very simple, easy peasy, right? Now let's check out number 42 now. The answer is 8 ampere. Number 42 says when a charge moves through an electric circuit in the direction of an electric force, it what? Now when the charge is moving in the same direction with the force inside a circuit, what happens? A, it gains potential and kinetic energy. B, it gains potential energy and loses kinetic energy. C, it loses potential energy and gains kinetic energy. D, it loses both potential energy and kinetic energy. Now when the two of them are friends, charge and force and electric force are friends, it will not lose, it will rather gain. So if the two of them are moving in the same, now this is the charge and this is the electric force here. If they are moving in the same direction, they will both gain, they will not lose. So the answer to that question is just it will gain potential energy and gain kinetic energy because the two of them are well aligned. But if one is moving in the opposite direction, there might be loss in the process. But majorly, generally, if the two of them are moving in the same direction, they will gain both kinetic energy and gain potential energy because the two align. So there will be maximum gain and there will be no loss, and that is the answer for number 42. Number 43 says to convert a galvanometer to a voltmeter, a what? Is it a high resistance is connected to it in series, a high resistance is connected to it in parallel, a low resistance is connected to it in series, low resistance is connected to it in parallel. Now this topic is under shunt and multiplier. You have heard about it before in the senior secondary class. Shunt and multiplier. Now this is a galvanometer and this is an ammeter and this is a voltmeter, right? Now a galvanometer can be changed into a voltmeter. A galvanometer can be changed to a voltmeter, okay? And it can function that way, and that's what we have. A galvanometer can be converted into a voltmeter by connecting a high resistance called multiplier in series to the galvanometer. So if you connect a multiplier in series to the galvanometer, it will be converted into a voltmeter, and that is the multiplier principle. The galvanometer must be connected in series with the must be connected in series in order to change it into a voltmeter. But that means that, and that's how a galvanometer can be changed into a voltmeter. But now a galvanometer can also be converted into an ammeter by connecting a low resistance in parallel with a galvanometer. If you shunt a galvanometer in parallel with low resistance, it will become an ammeter. But the question is saying to convert a galvanometer, that's the question is asking about the upper part. If to convert a galvanometer to a voltmeter, it must be converted, it must be arranged in series That means the I resistance, a I resistance called multiplier. A multiplier must be the multiplier must be arranged in series. That's to be able to convert this to this. So galvanometer to voltmeter is series, while galvanometer to ammeter is parallel, and that is it. So the shunt resistance must be in parallel for ammeter, but the shunt resistance, the multiplier resistance must be in series. If it is changing from galvanometer to a voltmeter, the multiplier must be in series. But if it is changing from galvanometer to an ammeter, the multiplier must the shunt resistance must be in parallel, and that is it. So it must be in, there must be I resistance is connected in series. That's to change from from galvanometer to voltmeter. I resistance must be in series, and that I resistance is called multiplier. So the multiplier must be in series, and that's the way we change from a voltmeter to an ammeter, and that is the answer. But if it were to be to that's how we change a galvanometer to a voltmeter. But if it were to be an ammeter, if you are changing galvanometer to ammeter, then a low resistance called shunt must be connected in parallel, and that makes the correct answer if it were to be an ammeter. But if it is to be a voltmeter, it is I resistance to must be in series, and that is the answer for number 43. 44. Induced EMF are best explained using what? Is it Ohm's law? Well, Ohm's law didn't talk about EMF. Ohm's law only spoke about voltage and current. That voltage is directly proportional to current. Okay, but that's Ohm's law. Ohm's law never spoke of electromotive force, EMF. Then Faraday's law didn't discuss EMF also. Faraday's law under electrolysis spoke about mass as directly proportional to charge. So mass is directly proportional to charge. Then Coulomb's law under electric field, the force, the force and the electric force as directly proportional to the product of charges and inversely proportional to the square of the distance apart. That is under electric field. But Lenz's law specializes on induced EMF, and that makes the answer to become Lenz's law. Now let's see what Lenz's law says. Induced current will oppose change. That is what Lenz's law said. So it will oppose the motion of the system. So induced current always move in a direction that opposes the motion of the system, and that's what Lenz's law said. So you can see it move in the opposite direction, right? Can you see? This is the current, and this is the magnetic field motion. But it is moving in. They are both moving in opposite direction. Can you see that? That's what Lenz's law said. That induced current move in a direction that opposes the motion of the system, and that's the magnetic field, and that is the answer to Lenz to this question. Induced EMF was best explained by Lenz's law. So the answer is Lenz's law. For the fact, in a circuit of 2.5 ampere, if a current of 2.5 ampere flow through an electrolyte for 3 hours and 1.8 gram of a substance is deposited, what is the mass of the substance that will be deposited if a current of 4 ampere flows through it for 4.8 seconds? Now this is electrolysis, and this needs Faraday's law. I always say that Faraday's law is the only law you will use to solve any question in electrolysis in physics, and Faraday's first law is the only formula to use for any question on electrolysis. You can see electrolyte through an electrolyte. That means that it is an electrolytic question. Okay, and the first Faraday's law is what physics focus on, although chemistry focus on both second and first. But physics, for some reasons, I don't know why, I noticed that physics focus on the first Faraday's law. That means you must have mastered the first Faraday's law, and that law is super simple. It is just M is directly proportional to Q. That is the first Faraday's law. That means the quantity of electricity flowing through an electrolyte is directly proportional to the mass of the electrolyte. That's just the first Faraday's law. And that's just it. Now I will use that formula now to answer this question. So M equals this directly proportional will change to equals to Z, and charge will change to current times time, and that is what we will use to solve this question. Now, so I will make Z the subject, that will become M over IT, and that is now, I'm now set. So now I have double of each. That means I have 2 currents, I have 2 time. So that means I have to make this formula to become double. That will become M1 over I1 times T1 equals M2 over I2 times T2. So now plug in your parameters. The first ones, all the first ones, 2.5 ampere, 3 hours, 1.8 gram are all given. But the second one, they say find the gram, that's the mass. So I'll just put, I'm finding M2, the second mass. So making M2 the solid, I'll be getting M2 equals M1 times I times T2 over I1, that's current 1 times time 1. Okay, I just cross multiply, and that's just it. Now plug in your parameter. M1, the first mass is 1.8, the second current is 4, the second time is 4.8 over the first current is 2.5, and the first time is 3. So multiply the up and divide by the one below. If I multiply 1.8 times 4 times 4.8, I'll get 34.56 over 2.5 times 3 is 7.5, and if you divide it, you'll be getting 4.6 grams, and that is your second mass, 4.6 grams. Don't forget that everything came from the Faraday's first law of electrolysis, which is mass is directly proportional to Q, giving me M equals the constant Z times IT. IT is Q, so Q became IT, that's current times time, and that is the answer to number 45. Use the Faraday's law, then multiply that law, and you get your value, and that is what to do for number 45 question. And any question on electrolysis in physics can be answered with this formula this way. Please don't forget, and that settles the last part of this video. Don't forget that if you learn something from this series and you want to get more content, click on like button. We have more content to share with you that will better help you understand. Take care of yourself, and bye for now.